Hello, I am Rajesh Kumar. As a previous lecture, we have studied about the different type of matters, mixtures and temperature scales, and in this lecture we will study about uncertainty in measurements, dimensional analysis and laws of chemical combinations. We will start with the uncertainty in measurement. Many times in the study of chemistry, one has to deal with the experimental data as well as theoretical calculations. There are meaningful ways to present the data realistically with certainty to the extent possible. Scientific notations. Scientific notations also referred to as standard form. It is a way to writing numbers that are too big or too small to be written in decimal form. In scientific notations, all numbers are written in the form a into 10 to the power b. Here exponent b is an integer and the coefficient a is any real numbers. Example 64000000 can be written as 6.4 into 10 to the power 7. Similarly, 0.00016 can be written as 1.6 into 10 to the power minus 4. 300 can be written as 3 into 10 to the power 2. As 0.2 can be written as 2 into 10 to the power minus 1. Similarly, 5000 can be written as 5 into 10 to the power 3. Some mathematical operations in scientific notations are like multiplication. Example, we have to multiply the 2.2 into 10 to the power 5 with 1.5 into 10 to the power 8. Similarly, we will first multiply to the coefficient like 2.5 into 1.5 and we will add the exponent like 10 to the power 5 plus 8. So, it will be 3.3 into 10 to the power 13. It is a mathematical multiplication operation. Second example, we have to multiply 3 into 10 to the power minus 2 with 2 into 10 to the power minus 6. So, again we will take the coefficient as 3 into 2 and exponent as 10 into 10 to the power minus 2 minus 6. So, the final answer will be 6 into 10 to the power minus 8. In division, suppose we have to divide 2.7 into 10 to the power minus 3 with 5.5 into 10 to the power 4. So, the solution will be 2.7 divided by 5.5, again 10 to the power minus 3 minus 4. Answer will be 0.4909 into 10 to the power minus 7. Addition and subtraction. For these two operations, first numbers are written in such a way that they have same exponent. After that, the coefficient are added or subtracted. Addition example, we have to add 6.65 into 10 to the power 4 with 8.95 into 10 to the power 3. First, exponent to be made same for both numbers as 6.65 into 10 to the power 4 plus 0.895 into 10 to the power 4. Now, in this case, the exponent has been become same. So, we will solve this 6.65 plus 0.895 into 10 to the power 4. Answer will be 7.454 into 10 to the power 4. Subtraction example, we have to subtract 2.5 into 10 to the power minus 2 minus 4.8 into 10 to the power minus 3. Similarly, as previous we have done, we will take 2.5 into 10 to the power minus 2 minus 0.48 into 10 to the power minus 2. Here in this step, we are making same exponent for making a subtraction. So, the solution will be 2.5 minus 0.48 into 10 to the power minus 2. The final answer will be 2.02 into 10 to the power minus 2. Significant figures. These are meaningful digits which are known with certainty. Significant figures give an idea of how will you could actually report your data. The uncertainty is indicated by writing the certain digits and the last uncertain digit. We will take one simple example. If we write a result as 11.3 milliliter, we say that 11 is certain and 3 is uncertain in this example. There are certain rules for determining the significant figures. As first rule is that all non-zero numbers like 1, 2, 3, 4, 5, etc. are always significant. Example, 285 centimeters has 3 significant figures and 0.25 has 2 significant figures. Second rule, all zeros between non-zero numbers are always significant. Example, 303 has 3 significant figures. Zeros preceding to first non-zero digits are not significant. Such zeros indicate the position of decimal point. This is the third rule of significant figures. We will take simple example. 0.03 has 1 significant figures and 0.0052 has 2 significant figures. Now the fourth rule, all zeros which are to the right of the decimal point and at the end of the numbers are always significant. Example, 0.200 has 3 significant figures. But if there is no decimal point, the terminal zeros are not significant. Example, 100 has only 1 significant figure. 100 point has 3 significant figures and 100.0 has 4 significant figures. Now the fifth rule of significant figure, counting numbers of objects have infinite significant figures. Example, 2 balls or 20x, these are exact numbers and can be represented by writing infinite numbers of zeros. After placing a decimal as 3 is equal to 3.0000 and 30 is equal to 30.00000. Now one point to be noted here, while limiting the result to the required numbers of significant figures, one has to keep in mind the following point for rounding off the numbers. As first point, if the rightmost digit to be removed is more than 5, the preceding number is increased by 1. Example, in 1.386, if 6 to be removed, then the result will be 1.39. Second point, if the rightmost digit to be removed is less than 5, the preceding number is not changed. Example, 3.334. If 4 to be removed, then the result will be 3.33. Third one is, if the rightmost digit to be removed is 5, then the preceding number will not be changed if it is an even number, and it will increase by 1 if it is an odd number. We will take example. Example, 8.35 will be 8.4 and 8.45 will be 8.4. Now the next is dimensional analysis. The methods used to convert units from one system to other is called factor label method or unit factor method or dimensional analysis. Example, a piece of metal is 3 inch long. What is its length in centimeter? We know that 1 inch is equal to 2.54 centimeter. So the conversion will be 3 into 2.54 is equal to 7.62. Second example, how many seconds are there in 2 days? As we know, 1 day is equal to 24 hours. So 1 day is equal to 24 hours is one factor unit, and 24 by 1 day, that is unit factor. Then 1 hour is equal to 60 minutes. So 1 hour by 60 is equal to 1 again unit factor, and 60 by 1 are is equal to unit factor. Then 2 day into 24 by 1 day into 60 minute 1 hour, 60 seconds by 1 minute. So, the final answer will be 2 into 24 into 60 into 60 is equal to 17,2800 seconds. As further we will move to that laws of chemical combination. The combination of elements to form compound is governed by the following 5 basic laws. These are: first law, law of conservation of mass. It states that matter can neither be created or nor destroyed. This law was given by Antoine Lavoisier in 1789. It was the result of exact measurement of mass of reactant and products and carefully planned experiment performed by Lavoisier. Second law is that law of definite proportion. This law was given by Joseph Proust in 1799. According to this law, a given compound always contains exactly the same proportion of elements by weight. As example, pure water obtained from whatever source, either in river, lake, etc., will always be made up of only hydrogen and oxygen elements combining together in the same fixed ratio of 1:8 by mass. Note, this law also known as the law of definite compositions. There are certain limitations of this law also. That is, the first is that this law is not applicable if the element exists in different isotopes, which may be involved in the formation of compounds. Second, the element may combine in same ratio, but the compound formed may be different. We will take the example. The compounds like C2H5OH, that's ethanol, and CH3OCH3, that's ether, dimethyl ether, both have molecular formula C2H6O. The ratio of carbon, hydrogen and oxygen is to 12:3:8 by mass. So, in the next lecture we will study about atomic mass, molecular mass, mole concept and molar mass, percentage composition, etc. Thank you.